Okay, that last vignette was a very inhuman way of computing a conformal map. We computed a grid of values in the z-plane, and we computed the images. We got another net in the w-plane, and then we connected the dots in order to get that. That's great for computers, and I'll show you computer-generated images that were done that way. But when humans draw conformal maps, they tend to like formulas better. So, for instance, if we want to look at the image of z equals minus 2 plus it, well, if z equals minus 2 plus it, where t varies from minus infinity to infinity, that's exactly a vertical line. And so we want to say, well, what happens to z squared plus 2z if z equals minus 2 plus it? We say, oh, you just work it all out, and you get 4 minus 4it minus t squared minus 4 plus 2it, which equals, let's use as much space as we got here. So 4, that's true, so we get 0. Minus t squared. That's the real part. So that's real, and that's real. And the imaginary part is minus 4it plus 2it, so it's minus 2it. So this says that the u part is just minus t squared, and the v part is minus 2t. That's a parametric description of a curve, and for some of you, calculus with parametric curves will be 2 years ago, and some of you it might be 1 year ago. You might want to have a look at it again, but it's not that hard. We can start with this parametric description of the curve, and we can eliminate one variable, and we can get a recognizable curve out of this. So u is minus t squared, and v is minus 2t. So we can solve this for t in terms of v, so that means t is equal to minus v over 2. And so that means u is equal to minus v over 2 all squared, which is minus v squared over 4. And that's a parabola. What kind of parabola? It's a parabola that opens that way. U equals minus v squared over 4. It's a parabola that opens that way. And that's the curve that we drew that touched the x-axis. That was the first one that we drew. And we drew it coming down and touching, going that way. So the fact that v was minus 2t, if t is negative, then v is positive. So if you start at minus infinity, you're starting with a large v, and you come down this way. So we got the directionality of our curve out of this as well. So this is superior for a bunch of reasons. One is that it tells you that it really is a parabola. On the other hand, that automatic technique that grind it out is very automatic, and away we go. So that's the image of a vertical line. The image of a horizontal line, let's see, where's my blue one? There we go. So z being, for example, t plus it, plus I times 1. So this says that the imaginary part is always 1, and that x runs from minus infinity up to plus infinity. So that's a horizontal line. So we just do exactly the same thing. We plug in t plus 1 times I in for z. And we get So now we get u is t squared minus 1 plus 2t. So that's u is quadratic in t, and v is 2t plus 2. So it's linear in t. So again, we can solve for t in terms of v, plug it in, and we get u is a quadratic function of v. But it turns out that the sign is positive this time, so that the curve opens to the right. And that explains why those curves in that graph were actually parabolas.